Welcome, this is Mrs. Boots, and we're going to take a really complex topic and break it down into simple little steps. This is simplifying using trig identities. The first thing we're going to do is find out what our trig identities are. So when we're simplifying, we're going to express everything in terms of sine or cosine. Our identities help us turn everything into sines or cosines. We're going to make all our trig functions the same, so if I can't get all sines or can't get all cosines, then I'll move on to tangent. We only want positive angles, we don't want fractions, and we're trying to get angles that are on the unit circle only. So we want to always go back to our unit circle. So let's look at our identities. So the first thing we have is our quotient identities and our reciprocal identities. The reciprocal identities are actually more familiar to you because you know in order to get cosecant, we did what? 1 over sine. Okay? To get secant, we did what? 1 over cosine. Okay, this is familiar, right? To get cotangent, we do 1 over tangent. So cosecant, secant, and cotangent are always the sine, cosine, and tangent flipped or reflected. But how do we get sine? Well, we can go backwards. So we could say that sine is 1 over cosecant. Okay? We say cosine then would be 1 over secant. And tangent would be 1 over cotangent. So if I flip sine, I get cosecant, but if I flip cosecant, I get sine. If I flip cosine, I get secant. If I flip secant, I get cosine. If I flip tangent, I get cotangent, and if I flip cotangent, I get tangent. Awesomeness. Okay, so now we're going to go back to our quotient identities. Super easy because you've actually seen these before, you just didn't realize it. On our unit circle, we said the tangent was the y over the x, right? My tangent was y over x. But then we said y values are sine and x values are cosine. So what we're going to do is we're going to plug in the sine and the cosine. So we say tangent is sine of x over cosine of x. Easy, right? Okay, so how do I get cotangent? Well, we just flip our tangent. So it's cosine over sine. So in this way, I can express everything in terms of sine and cosine. I can take my cosecant and secant, and I can take my tangent and my cotangent using the quotient identities and turn everything into a sine or a cosine. And that way things cancel out. So let's look at our Pythagorean identities. Pythagorean identities are a little bit more tricky, and yet they're the same. Okay, so for my Pythagorean identities, you guessed it, we have a Pythagorean triangle. So we have our nice little triangle here, right? And you guys know how it goes, right? It's a squared plus b squared equals c squared. That's our Pythagorean identity. Okay, well in the unit circle, c was always 1. My horizontal side, that's my x, was always cosine, and my vertical side, my y, my vertical side, the y, is the sine. So let's plug it in. So that means I have a cosine squared x plus a sine squared x equals to 1 squared, which is just 1. So the Pythagorean identity, I can express a squared, b squared, c squared in terms of sine and cosine. This will also help me simplify. Okay, well what happens if we rearrange this a little bit? Okay, so I could subtract and move cosine to the other side. And I get sine squared x equals 1 minus cosine squared x. Alright? Well, what if I subtracted the cosine or the sine instead? Cosine squared x equals 1 minus sine squared x. So for all of these, I can rearrange this. All I'm doing is adding or subtracting, move it to the other side. Well, there's other things I can do. What if I have a bunch of cotangents or tangents? So let's divide everything by sine squared x. This gets a little confusing, but it's not a big deal. So if I take sine squared x plus cosine squared x equals to 1, and I divide everything, each one, by sine squared x. Okay, well, sine x squared divided by sine squared is just 1. That's easy. Cosine over sine, we just learned that's cotangent, so that's cotangent squared x. And 1 over sine, that was cosecant squared. Okay? So I can write the same Pythagorean theorem as 1 plus cotangent squared x equals cosecant squared x. Not a problem. I could then subtract and move things around. So I could say 1 equals cosecant squared x minus cotangent squared x. Okay.
You don't know, I'm just getting it.
Alright, so what if I want the cotangent by itself? Well, that's easy, right? So I would subtract the cotangent to move it over, and subtract, oh wait, you know what, I'm doing that the long way. Forget that, let's just subtract the 1. If I subtract the 1 from both sides, now I have my cosecant squared equals, my cosecant minus 1 is equal to my cotangent squared, alright? So I can get the cotangent by itself, I've got the cosecant squared by itself, or I can have the 1 by itself. Any of those three. Okay, well what if we were to go in and divide by sine squared? I'm sorry, we just did sine squared. I got interrupted and it messed me up. So what if we divided by cosine squared x? Okay, so let's take our original theorem. We got sine squared x plus cosine squared x equals 1. Divide each of those by cosine squared x. Okay, well sine over cosine, that's going to be tangent. So that's tangent squared x. Cosine over cosine is 1. And 1 over cosine, that's secant squared. So my Pythagorean theorem works with tangent squared x plus 1 equal to secant squared x. Alright, same thing. I can subtract the 1 to get the tangent by itself. So then I'd have tangent squared x equals to secant squared x minus 1. Or I can move that secant over. So that I've got negative secant squared x plus tangent squared x, I could have written it as tangent squared minus secant squared, equals that negative 1. Okay? Or you could flip the signs and say, okay, I want positive secant minus tangent equals to positive 1. Okay, you can do this in a number of ways. The important thing is to remember your basic equation. Sine squared x plus cosine squared x equals 1. And you can rearrange it to get any of the other Pythagorean identities. We're now going to do some examples of each one of these and how to use them.